Hello and welcome to a recorded talk about r2u, CRAN as Ubuntu Binaries. I'm reusing the slides from a presentation I was invited to give at the 11e Rencontres R, the 11th R meetings in French-speaking Europe that were held in Mons, Belgium last week. There we had some initial setup difficulties with the display system and the laptops, so I forgot to set my timer and oddly enough ran out of time, even though I was given 30 minutes, and the last time I talked about this was only 20. So I thought may as well re-record this and see where we're at. So r2u is a pretty specific and one could argue narrow solution for one particular vertical stack, Ubuntu. And while it may seem very narrow, the goal of the presentation, the slides, this talk, is to convince you that it may still be of real interest to you. And for that, I will describe a few things throughout the course, pardon me. The key issues that we're talking about is that we care about CRAN as a very unique repository, which is actually offering binaries for Mac OS and for Windows. And we are now adding Ubuntu. We are doing this as a full integration with system binaries, and that we argue offers unique opportunities that other systems don't have. And we're doing this in a widely used platform, namely Ubuntu. The focus and country of this contribution is basically the desirables that we want: very fast and automated task execution and fast feedback loops. There were a couple of very decent blog posts in the last couple of years. Julia Evans wrote about this. Eric Bernhardsen wrote about it. Fast feedback loops are really critical in development because we don't want to wait for our work. And this matters particularly for CI, but also when setting things up. So we want things to be fast, easy, reliable, without really any surprises and no breakage. We'll get to a particular example of possible breakage later. And of course, we want to access this on the platforms we actually use, common ones. Constraints of this particular setup is we are in one particular vertical, namely Ubuntu. But as I mentioned later, similar setups have been built for other systems as well. And what we do here is specific to R, but could be generalized to other application languages. However, our focus here is R, our tool of choice. It's how I analyze, slice, and dice data, teach about it, but it's really about reuse from a particular source repository. So one could, in theory, build the same thing for Python, Julia, Rust, you name it, any other language with a decent repository. I should mention, of course, and if you're familiar with R, you know that CRAN has a couple of unique aspects that help, and the quality control is a big one. We're also focusing here on deb binaries. No particular reason other than that's what I've been using for 30 years, the 30 years that I've been contributing to Debian and hence Ubuntu. I'm familiar with the format, trust it, know it, and it just works for me. The same thing can be done and has been done for RPMs. Iñaki has copper to CRAN, and one could probably do the same thing for Brew or other package systems. But it's my project. I built it for myself, so I built it as deb binaries around Ubuntu. And we're equating deployment here with Linux, simply because Linux is very prevalent on all cloud and server settings. Someone from the top level management of Azure at Microsoft was quoted the other day that more than half the CPU hours are actually spent on Linux rather than Windows systems, even at Microsoft. The marginal cost of zero is sort of hard to beat. And among these cloud systems, Ubuntu has a fairly prominent position, so why not stick with this? So why are we using CRAN? Well, the good news is it's a really high quality repository with stringent quality control. What also matters is that it is set up not dissimilar from Debian testing or other rolling distributions. Everything builds at head That's an expression Google uses. They have a billions of lines code repository, and whenever changes are made, the whole thing still needs to build. In essence, CRAN attempts to do the same and manages to do so. Whenever something gets added to the repository, it is tested for possible side effects on what is already there, and if it were to create such side effects, it's not admitted. As such, it's generally at any one point in time buildable, reliable, workable, and that makes it really suitable for scripting. You can just take random snapshots at random points in time and be relatively certain that everything will just work. Now, CRAN has been around for 25 years. They just had that anniversary, and there are still some things that we're not so happy with, and one of those affects life when you're a Linux user. In general, CRAN only offers you source packages, and you yourself are forced to do the compilation. There are alternatives now. p3mdev is one, and we talk about that a little later. But generally speaking, as far as CRAN is concerned, the official word is it's from source, and that's generally slower and more error prone. Linux distributions, on the other hand, offer help. They group packages, generally in cohorts, releases, organize dependencies, and integrate everything in such a way that it just works. We can differentiate distributions by vertical and horizontal terms that I use here to mean vertical in the sense that it's all the way up from the assembler, linker, compiler to the application scripts at the very top, and horizontal being more focused on the actual applications across possibly different deployments, hardware platforms, Linux distributions. And our focus here is very strongly on the vertical case, Ubuntu. So why Ubuntu? Why this particular one? Well, it's pretty good, pretty complete, pretty current. When you talk to Linux users, there's many choices. Different people have different preferences. Someone likes Arch, someone likes Fedora, someone likes Gentoo, Pop! OS, what have you. But Ubuntu is pretty good, and from all the, of course, there's no sales figures for open source. Surveys one can see pretty widely used. It is also quite polished, has a professional team behind it, the security updates are very good, and all this makes for widespread use. For example, GitHub Actions supports one and only one Linux flavor and installation. That happens to be Ubuntu. Similarly, Google Colab also supports one, and that is Ubuntu. If you've picked Ubuntu and want to work with it, you have relatively decent support from third parties. Intel, for example, offers the MKL or TBB, used by Raspberry Parallel. NVIDIA, of course, has SDKs for its GPUs, and many applications that we may want to use, for example, the editors, are available there. Distributions, of course, have package managers. And so it's worthwhile stopping for a second and talking about what a package manager does. In a distribution, it generally runs as the system user, root, and installs system dependencies. This means it has full reign and reach over everything the distribution may need to use, and can install dependencies, possibly with pin. However, what is outside the distribution cannot be packaged. So while a subset of CRAN is in Debian or Ubuntu, not all of CRAN is there. And that opened the hole that we're trying to plug here. Package managers also exist in an application. In R, of course, we have install.packages and related less widely used functions like update packages when you have packages already. They generally work quite well in the context of the application. PyPy gets you your Python things, the R application manager gets you your R things, but they cannot deal with system dependencies So there can be occasional frustrations, setup difficulties, because you really are playing two games at the same time for certain applications, and that can be tedious. So what we're doing here is joining the package manager applications across those two fields. The one that's used in the distro, we also use for the app. And we argue that this is uniquely powerful simply because you can reach down to the system level for the dependencies that the application layer needs. This is not an entirely novel idea. In fact, it's been done for 25 years. And in the Ubuntu case, I've been involved with quite a few of those, and we never quite got to that. The very first one was actually done for CRAN when CRAN was still only around, I think, 100 packages, and Albrecht Gebhardt in Austria did this with the Perl script. A few of us picked up that Perl script a little bit later and did some work. I also had one really excellent Google Summer of Code student, so at some point we had several thousand packages. Don Armstrong, another Debian maintainer, and also quite involved with the distribution, did a larger repository while postdocing. Both of these blew up for hardware failure and lack of backup, so that's a little sad. But anyway, those are stories. Iñaki and I write a little bit about scope of all of this and the past in the archive paper, and what's linked here in blue is a link that you can get to from the PDF page. And so in that sense, r2u really is the first one that got all of this working in the Ubuntu case. But I should note, of course, that Iñaki did this already for Red Hat Fedora, and Detlef did it for OpenSUSE. So it's not entirely novel. So what really is r2u? In a nutshell, it gives you the ability to say apt, install, and then the Ubuntu package name of a CRAN package. Because distributions have their own namespace, one has to be careful not to clash. When I initially packaged a couple of packages for R, actually this goes back to Doug Bates, starting with the R package I later took over from him. For example, we packaged the CRAN package boot as source package boot in the distro, but we renamed all the binary packages to start with r-cran-name of the lowercase package. That is a convention that works well for other application systems too. The distribution then wraps around this R installation and makes sure that as a distribution package, everything is actually resolvable, gets resolved, and is installable. We are doing this now for the 3 LTS releases, long-term support releases that Ubuntu offers, the current 24.04 and the preceding 22.04 and 20.04. We initially did this just for the Intel chips common in PCs, and we're now also doing it for the ARM chips, which is a chip family underlying the Mac laptops, but also everything up from the larger Raspberry Pis to servers in the big data centers. ARM64, sometimes called Cortex for the laptops, Ampere for the servers, and the cloud services have their own sort of code names for that, but it's expected to be becoming more popular as more hardware will be coming out as an alternative to the PCs. So we started doing this too more recently. Now, what else is there? And first and foremost, there's p3m.dev by POSIT, formerly known as POSIT Package Manager, and even another name before that, I keep forgetting now. It was also preceded by something that Microsoft had done with the MRUN archive, and p3m.dev really is very, very good. It has a broad breadth across a lot of hardware platforms, operating systems, and versions. It also adds support for multiple R versions, so if ever you need to run R from 2 years ago, it will probably cover that as well. And it does something that we're not doing here at all, namely the time machine feature, that if you want to install as of February 15th, you can do that too. We do believe more in everything built and head which is the way of thinking Debian has, CRAN has, as I argued, Google has, and that sort of works for us. But choices are good, so if you want to have the other system, you can actually get this from p3m.dev. So it's quite good. Most of the time, p3m.dev gives you binaries. Oddly, sometimes it gives you source packages, and I have not found a way yet to tell ex ante whether one will get a source or a binary package. So that can be a little tedious. And of course, most importantly, it does not offer system integration. So if a package requires other installation, there are some add-on services you can also query, and leading to commands that you have to do that deal with that. This got wrapped back up again, I believe, into pack, which does that for you, but not going there, not doing a direct horse race comparison. We're focusing here on the direct into the distro integration that we can do, because we talk to apt, and that's sort of our focus. But if you're happy with pack and p3m.dev, by all means use it. It's all good. We're basically playing on the same team for the same goal here, even though they do things slightly differently. So there's no better or worse. If it works for you, great. What are advantages of system integration? Well, in the narrowest sense, really, it just gets you everything that's needed. If you install a package that wants to talk to a database and needs the binary database drivers, they will now get installed. It's that simple. Whereas in the other systems, you may not get a binary because only a source package is there because it has been built against it, or like. And also, very importantly, and that's a case where the alternatives will fall short, because if you keep the application package manager separate from the system package manager, then the system package manager does not know what the application uses. A classic case can be when you have a shared library built to its major version. That's very common in the Linux distributions. And you install a particular version. You then run with your system for a couple of months, upgrade it, and get a new version of that shared library. So you go from n to n+1. At this point, your binaries that are not managed by the systems have been built against n and may get removed because the system package manager does not know that the application has moved from, the system has moved from n to n+1, but the system does not know that the application is still built against n, so it is left hanging and will no longer run. That has happened quite a few times, for example, with the package here. It's a worked example that you can reproduce in via Docker binaries that I put in a demo repo. What happens here is my package rcpp Ziggurat looks at a very interesting, simple and fast N01 RNG. And when I set the package up, I was mostly concerned with comparison to other existing implementations of Ziggurat, one of which was in the GSL. So I made this package dependent on the rcpp GSL package, and the GSL itself, so that I could run this. Turns out that I would have rcpp Ziggurat built in user local as the R package, and on my main machine, every 6 months update to a new Ubuntu release, and every now and then I would get a new GSL release. And in this Docker container, I sort of reproduce those steps and show it. GSL releases have slowed down a little bit, but between two Ubuntu releases, we still had a jump from 2.3 to 2.7. So the binary packages libgsl 2.3 and 2.7 are the two here. If you initially install and build against 2.3, update to 2.7, the 2.3 version disappears and your R package is left hanging and no longer works. If you do the same with r2u, now in an r2u container rather than in a generic Ubuntu container, it does not happen. There are two ways that this can get solved. Either the package manager knows that there's still a package using libgsl23 and keeps it, or what happened here in the normal case, because the package is available in the same repo, you just get a rebuilt version of the package at hand, here ACBP Ziggurat, and its use just transparently moves from libgsl23 to 2.7. This is not an imaginary breakage case. It's easily demonstrable, and these two blue links behind me on the right hand side of the slides give you reproducible code and examples that show this. So, abstracting away a little bit from this, what can happen to you at any one of these cases is really that you have a particular version shared library, you roll to the next version, the package manager doesn't know that a client package uses it, it updates the library behind the back of your application, and your application is left stranding. That can happen with libgsl and those two-digit versions. It can happen a lot with libicu, which famously gets used by Stringy, which is used by String R, and many other versioned shared libraries. So that's basically a will not break guarantee that you can only establish and deliver if you integrate your application management with the system package management. This may or may not matter greatly to you. I've been bitten by this, and I quite frankly find it tedious. This is not, to me, the single most important reason for using r2u. The single most important reason really is just the speed and the ease and the reliability. But that things don't break behind my back is a really nice additional benefit. How does one use r2u? Well, there's a little bit of a peanut butter and jelly aspect, because Iñaki, sort of independently, wrote a really clever package called Bridge to System Package Manager that his copper to CRAN uses. It's not specific to r2u, but it works with r2u because it supports apt, just how it supports other package managers on other distros. He traces the installed.packages call and then redirects it to a little bit of Python execution. When you're installing a package, say install.packages, as in the examples on the slide here, xgboost or mlpack, it will check whether it knows about a package r-cran-xgboost, r-cran-mlpack, and if so, install those by dispatching to apt. At this point now we're in the system, and it's treated like an apt binary, meaning that all other dependencies and shared libraries will get pulled in. It's really powerful because the R user does not need to know about the naming convention, that the binary is really called r-cran- whatever the package is. We will just continue to refer to packages the same way we do at CRAN and use the same commands. We use install.packages. Moreover, because remotes uses install.packages when it passes, for example, description files to install all dependencies, we have now a really convenient and powerful way to just point at a description file or repo containing a description file and say, get me all the dependencies. It does so, and it will fall back to binaries whenever these are available. Really, really useful and really powerful for CI use. And my RCI, for example, uses that. And here's a particular example. I realized once I was due to give the presentation that I should, of course, have rewritten this to show R script use rather than shell use, but this, for historical reasons, goes back to the predecessor of a CI setup that we all used for Travis. I continue to use this and look after it, and this really is all there is. In the repos, I tend to have a little bit of write space between these paragraphs, but we have a matrix with two operating systems. For Ubuntu, it uses r2u. For macOS, it just falls back to the standard binaries that we have. By invoking the script, it knows whether it's running on macOS and dispatches those commands the appropriate way, or on Ubuntu and relies on r2u. And in essence, there are just two meta declarations after we've done the setup, which is for this particular repo, get me all the dependencies that I needed. And that's all we have to say here. And it generally just works. And run tests, then builds the targz and runs our command check over it. Reliable, fast, easy, no headaches. And most of the time I don't even bother with macOS and just run Ubuntu, but just a personal preference of mine. If you want to run two of these, you can. If you also want to run Windows, well, then you are probably best off to run the usual setup from uses or something else. I tend to not run that much Windows at CI. Having said all of this, a little bit of background before we close. What really is in a binary package that we use here? It's really not that far away from what R and CRAN can already do and do, because you can create yourself binary packages. That's what p3m.dev ships. This is what you can do locally if you want to fill a repository with binaries. You simply say r command install -- build from the particular source repository or targz that you're pointing at. What I'm showing here is a screenshot that's, I think, unedited from a small package of mine. This is not the replacement package, Zig, which revisits Ziggurat, but much simpler and no external dependencies, just the random number generator, no headaches. And it is currently at version 002. And you see that when you run such a binary, you get yourself a targz on Linux that reflects the architecture that you're on and the OS. So they can sit next to binaries on other operating systems. But that's just it. It's just a tarball. So I refer to these as naked binaries because they do not contain any system information, any meta information, any entitative information that deb binary would have. But when you're building a deb or RPM, it's a little bit of sort of specialized knowledge. I just happen to have started there with open source work as a grad student by first looking after deb packages. So all of this became a little bit of second nature. You get something that's an outer wrapper around the inner targz with additional files, as well as with additional declaration that are in the outer layer. You can query these. For example, apt-cache.show shows you that for a package on the repo. And here I'm pointing on to a particular geospatial package, because the geospatial packages have given some of us repeated headaches about installation with matching or not matching versions between the different geospatial libraries. And this one just shows the particular ones that this binary is built against. It also, in this case, shows a little bit of what's currently happening in the distro. This is basically an accommodation happening now so that we don't have a year 2038 meltdown, just how the year 2000 would be one, by moving the variable used for time increments to a larger range. So some libraries needed to get rebuilt, and that's why they have the suffix. Otherwise, it's still, libgbl 34. Otherwise, with a version of 3.8 or larger. Non-naked, so distro binaries have this additional information and can bring all these other packages in. Similarly, they bring CRAN dependencies in. If you opt into it, can bring suggest in. I usually don't, keep it narrow. And that's at a very high level the difference between naked and distribution binaries. More meta information, whereas naked ones don't have any at all. So how do we do this? Well, we use the actual tool chain that the distro uses. So this is no different from building the official packages that I ship into the distro as a distribution developer as I am for Debian. So we use the same formal tools, we just put them in a different repo. Not into Debian or Ubuntu itself, because they are just like CRAN. Every new package needs a human to inspect it. It's not particularly quick, so it's completely out of scope to throw 23,000 packages that way. Can't do. But we can do it in add-on repos, just how many other add-on repos exist for everything from Zoom and Spotify to Chrome and SyncThink and whatever else code. The big insight that I had here at one point 3 years ago, when I realized that p3m.dev actually gives me binaries, is that I could just sit on top of these binaries and save the inner build script step that a full package would use. So I'm currently doing that where I can, just to make it simpler and quicker, but it really just corresponds to the r command install step that I could otherwise do explicitly, as we've done in the previous approaches. I may switch back to that for some other things. I do this. For example, for Bioconductor, I also cover about 500 packages, which is sort of the top 250 by usage plus their dependencies. Those are built from source. Similarly, the ARM86, the ARM64 binaries are also built from source. So it's a bit of a mix and a match, but for the time being, when I can use them, I do reuse the p3mdev.binaries, which also means that I follow their release cycle, and they're generally available in my time zone the morning after a CRAN release, and then I just update r2u. And those get then put on a mirror that sits in Urbana Champaign, as I'm friendly as a part-time prof there with someone in tech support who lets me have a VM to distribute that. They're quite used to having a large mirror because they have a C10 mirror there, so it's all good. How, if one likes this, how does one go about using r2u? Well, the website has a script you can run, or in the README goes over the 5 steps in the script and discusses them. You can and should do those by hand and carefully because it involves root usage, so we're not trying to pull a fast one over you. The same steps are otherwise also used in thousands of runs each day in CI at GitHub. They basically just consist of adding the apt repository to the knowledge of the Ubuntu machine that you're running. So when you update and inquire about available packages, it now also sees these 23,000 new added CRAN packages and 500 some Bioconductor packages. There's a GitHub action if you want to do that in CI as well. And or you can of course experiment with Docker. That makes it really quick for debugging, for one-off tests. Sort of I do this basically all day long. So we have Rocker r2u containers now for these 3 Ubuntu flavors. This has gotten quite popular, which is very exciting to see and very pleasant. I started out around just talking to a few friends and having them tested in the spring of 2022, 3 years ago, and then during 2022 gave a few online talks at our user groups, and usage really started to pick up a little. There was a very amusing large spike that we see here, and this is on logs. This is cumulative loads. For 2 days, a machine per its IP address in Europe somewhere was apparently misconfigured and downloaded, I think, 1.5 million over 2 days. So of course that's still total there. Otherwise, we're slowly getting to the point now where we're doing more than 500,000 a week. So it's quite good. When I last ran this in the beginning of May, it came to 42 million total downloaded over the lifetime. Given that it's the end of May now, we're probably now closer to 44 million. Summing up, what is r2u about? What did I talk to you about here? It's a working demonstration that we can actually integrate application repositories fully into a Linux distribution. We do this here with CRAN. One could do it with other languages too. We do this because we feel quite strongly that it gives you a sum of 2 things being greater than the sum of the 2 things individually. Having the application packages available whole gives us the ability to script reliably, fast, easily to get installation going. The system also extends and generalizes a little. Something that we don't really pay that much attention to as CRAN packages is that there really is a difference between the packages with native code and those without. At the CRAN level, it's about 5,000 of the 22,000 that have binary code. They correspond to, Anyaki once broke that down to about half the downloads though. But the nicer aspect is that the remaining 17,000 that in this particular case we already built for use on AMD 64 standard, Intel AMD Linux, are what the Linux distribution calls binary all. They are not dependent on a particular architecture. So when I wanted to make r2u available for ARM64, I did not have to rebuild those 17,000. They're simply used from the same repository as binary alls. That's how the file name is set up. So in order to go to another hardware platform, we merely have to build the 5,000 binary packages. So that I actually did then at GitHub Actions, because they now give us ARM64 Linux runners. I don't actually have an ARM64 machine at my disposal, so I did all of this there. That means we could possibly go to other hardware platforms and or could do other distros, but that's sort of to be seen. The main thing is we have a working and quite successful model for setting something up. And what we've done here is not really limited to Ubuntu or R and CRAN, but could be done equally for other setups if there's a demand for it. One more thing that's useful to mention is that you can mix and match these full distro binaries, of course, with naked binaries. Jeroen has been quite successful with the R universe. A couple of other people are now building the R multiverse on top. You can also use install.packages with a particular repository setup that corresponds to your setup. So I happen to be running 2404 Noble with R4.5, so I would use this installation string. That's a deployment that Jeroen supports with binaries. So with these two lines, I actually get GlareDB, a Rust product, and Polars, a Rust product, installed pre-made from our universe onto my system in 23 seconds. While they're naked rather than full dependency binaries, they don't, in this particular case, need anything else, so they just work, and that saves me compilation time and effort I would otherwise have. So you can quite easily extend your use in containers, on servers, in CI to additional binaries. I have created a number of small videos and keep posting those. They're now mostly collected in a repo images in my GitHub, and here are a couple of links of particular ones that I've shown. This was just to support some things that I did on social media. So Tidyverse, RStan and BROS in 33 seconds, Tidyverse by itself 20 seconds, and so on. So look at that repo and see a few more. I may add them to the r2u website, but otherwise these are small sort of amuse-gueules to just see where you're at. And that's it. Thanks for hanging with the talk if you're still here, and the video, and I'm quite grateful to everybody listed here, from our package authors and the CRAN team down, and of course everybody who had worked on and helped with predecessors to r2u, as well as all the tools involved. So thanks to Posit for p3m.dev, to Iñaki, Rami for hosting, and my GitHub sponsors for the coffee money that gave me all the drive and energy to write the first prototype of this in a weekend. And go to Edelbittle, github.io/r2u for the documentation, and I hope you'll get to try, experience, and enjoy r2u. Thanks.